Hello everyone, welcome to this video in which we are going to learn about the definition of oxidation number, and we will see how do we calculate oxidation number in various molecules. To understand the definition of oxidation number, let us take a simple example of a reaction between a sodium atom and a chlorine atom. We are interested right now in the transformations that these atoms are undergoing during this particular reactions. In this particular reaction, the sodium atom is losing one electron and getting itself transformed into sodium ion Na+. Similarly, the chlorine atom is gaining one electron and getting itself transformed into chloride ion. Now these ions are interacting among each other through electrostatic force of attraction and finally giving us our product, that is NaCl. Okay, now we would like to assign particular numbers which will help us to keep a track of these particular transformations in each of these atoms. We can do this by assigning the overall charge that is developed on this particular atom before and after the reactions. Before the reactions, the sodium atom right here has equal number of electrons and protons. Therefore, overall charge on this particular atom is 0. Alright? But after the reaction, since it has lost one electron, there will be one proton more than the number of electrons, and therefore a net positive charge will develop over sodium atom, which will have a unit of 1. So a +1 charge gets developed over sodium atom. Similarly, before the reaction, chlorine atom has equal number of electrons and protons. Therefore, the net charge over this atom is also 0. And since it has gained one electron during the reaction, it has an excess of electron than the number of protons. Therefore, it will get a charge of -1 over it. Okay, so let me assign this particular number right here in our chemical equation. Before the reaction, sodium atom has 0 charge over it. Chlorine atom also has 0 charge over it. After the reaction, in the compound NaCl, sodium atom has +1 charge over it, while chlorine atom has -1 charge over it. Now, if we have to exploit these particular numbers that we just assigned, we can see that these particular numbers are also telling us, or also giving us information about the loss or gain of electron from an atom. If we follow the route of sodium atom, we will conclude that in this particular route there has been a loss of electron, loss of one electron specifically. Similarly, if we follow the route of chlorine atom, we can conclude that there has been a gain of electron. Okay, so by assigning these numbers, we can get the information about the loss or gain of electron that has taken place during this reaction, and therefore we define these particular numbers as oxidation numbers. Okay, and the purpose of calculation of oxidation number is to track the particular loss or gain of electron between atoms and molecules in a chemical reaction. So in the remaining part of this particular video, we will focus on the rules which will help us in calculating oxidation numbers of various atoms in a particular molecule. Okay, so let us move ahead and see these rules. The first rule for calculating the oxidation state is a follow-up of what we have just studied. An atom in its ground state will have oxidation state equal to 0. Okay, so we have just assigned the oxidation state or oxidation number to sodium and chlorine atom in our previous example, and same is applied for all atoms which are present in their respective ground state. Ground state means that it should not be combined with any other atom. Okay, it is on its own. If such is the case, we will assign it an oxidation number of 0. We can also understand the second rule of oxidation number calculation, that is, if an atom is charged, then the oxidation number will be equal to the charge present on that particular ion. Let it be a positive charge or a negative charge. So in this particular example, the oxidation number of Na plus will be +1. Similarly, the oxidation number of Mg2 plus will be +2. For chlorine, it will be -1. For oxygen, it will be -2. For nitrogen, it will be -3 in their respective ionic forms. Okay. Some metals and non-metals have particular oxidation state, and this oxidation state never changes. So this particular rule is going to be very helpful in calculation of oxidation number in a lot of examples. So first of all, we will list down the group 1 metals that will have an oxidation state of +1 always if they are present in any compound. So we just saw the example in NaCl, sodium had an oxidation state of +1. Similarly, the group 2 metals will always have an oxidation state of +2 no matter what, or no matter to whichever atom they are combined to. And finally, fluorine is a non-metal which has a fixed oxidation state of -1 in all of its compound. So if we ever found these listed elements in the rule number 3, we can be certain to assign the oxidation number as per this particular rule. Okay, so we will keep this in our mind while applying the rules. Let us move ahead and see some more particular rules. For oxygen atom, there may be variable oxidation state possible as per the presence of oxygen atom in that particular compound. In most of the cases, the oxygen atom will have an oxidation state of -2. That is, it remains present in the form of oxide ion. However, it may be present in the form of peroxide ion, in which case the oxidation state of oxygen will be -1, or in superoxide ion, in which the oxidation state of oxygen atom will be -half. Alright, we will see particular examples of such cases, and if oxygen is connected to fluorine in any compound, then we can be sure that its oxidation state is going to be positive. Okay, so these are the various rules for calculation of oxidation state of oxygen atom. For hydrogen, it shows two oxidation states. If it is connected with metals, then it will have an oxidation state of -1. If it is connected to non-metals, then it will have an oxidation state of +1. Okay, so we will add it in our list, and let us finally see the rules for halogens. Halogens, as we just saw, for fluorine it is always -1. For rest of the halogens, that is chlorine, bromine and iodine, we will see that the oxidation state will be -1 in general cases. However, if they are connected with oxygen in any compound or ion, then we can be sure that their oxidation state will be positive. They will get a positive value of oxidation state. Okay. So with all the rules that we just discussed, let us move ahead and apply them for calculating oxidation states. To calculate the oxidation state of an atom in a molecule or ion, the sum of oxidation number of all the atoms present in that particular molecule or ion should be equal to the net charge present over it. We should use this final rule in order to calculate the oxidation number of an atom that is unknown to us. Okay, so let me apply this rule for calculating oxidation state of carbon atom in carbonate ion. Since the oxidation state of carbon is unknown, let me mark it as X. The oxidation state of oxygen can be known from the set of rules that we have studied. In most of the cases, the oxidation state of oxygen is going to be -2. Now, we will use this rule in order to write the equation for calculating the value of X. Okay? As per this rule, we have to add the oxidation state of each atom present in this ion. So, the oxidation state of carbon is X. This will be added to the oxidation state of oxygen atom. In one oxygen atom, the oxidation state is -2. Now, since there are 3 oxygen atoms, we will multiply this value by 3. This is the sum of oxidation state of all the atoms. And now we will equate it to the net charge present over the ion, that is equal to -2. Okay, so moving ahead, we will simplify this equation as x minus 6 will be equal to -2, and finally we will get the value of x as +4. So the oxidation state of carbon in the carbonate ion is +4. Let me take another example of calculation of oxidation state. Here we will calculate the oxidation state of nitrogen in the molecule HNO3. Let me directly come to the oxidation state equation. The oxidation state of hydrogen is +1. We will add it to the oxidation state of nitrogen. Since it is unknown, let me mark it as X. And the oxidation state of oxygen is -2. And since there are 3 oxygen atoms, we will multiply this by 3. This sum should be equal to the overall charge present on the molecule, that is equal to 0. Okay, so once we have got this equation, let me simplify it as x minus 5 will be equal to 0, and hence the final value of x is equal to plus 5. So the oxidation state of nitrogen in HNO3 is plus 5. Okay, we can see that the application of same set of rules is applicable for any molecule. Following these rules, we can calculate the oxidation state of an atom that is unknown to us. In the upcoming video, we will be taking up more examples of calculation of oxidation state. Thank you so much for watching. See you in the next video.